to be investigating the photoelectric effect. The photoelectric effect occurs when light falls on a metal surface. If the light has a certain frequency, it can cause electrons to be ejected from that surface. The basic experimental setup that you're going to have is you're going to have a light source which is going to shine onto a cathode which is covered in a metal. If the photons from the light source have enough energy, they will cause electrons to be ejected from this metal. The electrons will then travel towards the anode, where they will be detected as a photocurrent. During the experiment, you're going to place apertures and filters between the light source and the cathode, and you're going to look at how this affects the generated photocurrent. The theory you need to know for this experiment is that the energy of the photons is given by hf, where h is Planck's constant and f is the frequency of the photons. The maximum kinetic energy of the electrons that are ejected from this surface is given by hf, which is the energy they get from the photons, minus the work function, which is the amount of energy you need to put in to cause the electrons to be ejected from the metal surface. What you're going to be measuring is the stopping voltage, because what we can do in this experiment is we can apply a voltage between the cathode and the anode, which is going to make it more difficult for the electrons to travel from the cathode to the anode. When the stopping voltage times E is equal to the energy that the electrons have, the electrons can no longer travel from the cathode to the anode. So measuring the amount of voltage we need to apply to make the photocurrent zero is going to give us a lot of information. We have this equation here. E times V, where V is the stopping voltage, is equal to HF minus phi, where phi is the work function. In this experimental setup, the cathode and the anode are located inside this box here, and we can use the knobs to, this one will adjust the backing voltage, and then this second knob will let us read either the current or that backing voltage. The light supply is here, so we connect the light supply into an AC power supply. And it's important to always have a filter between the light supply and your black box, because this will prolong the life of the anode and the cathode. What you're going to do during this experiment is, to start with, you're going to insert different apertures between the light supply and the cathode. There's a little slit that you can just slide them into. To do the first part of the experiment, you need to check that you've selected experiment 1A to E on this first knob. We need to set the backing voltage to 0. So on the meter reading, select the backing voltage and then adjust the knob so that the backing voltage is as close to 0 as you can get. In this case, 0.001 is as close to 0 as you can get. What you're going to do now is investigate how the number of photons hitting the cathode changes as we change the aperture size. So to do this, you'll need to record the current with different apertures. So to record the current, switch to the low current. With this aperture, there's 154 nanoamps measured. With a smaller aperture, we'd expect to get less current. And you do see we get less current, 17.3. So you'll need to record this data in your table and then plot the appropriate graph. In the second part of the experiment, you're going to be measuring Planck's constant and also the stopping voltage of the metal that is placed on the cathode. You're going to do this by putting different filters between the light supply and the cathode. You'll be provided with 5 filters. Each of them has a wavelength marked on it. The filters will only let through wavelengths of an equal value or greater than the wavelength written on them. So what you're going to do is you're going to place the filters between the box and the light source, and then you'll work out what backing voltage you need to apply to get this photocurrent to 0. So choose the current setting, adjust the backing voltage knob until it just goes to 0. And then switch this second knob to the backing voltage so that you can read what that backing voltage is. You'll need to record that backing voltage in your table and use that to calculate Planck's constant and the work function by fitting it to the equation that we had on the board.